Hello everyone, welcome back. I'm Vaishnavi Kumbharkar from B Computer. Today, I'm really excited to share with you my project, Crypto-Mining Malware Detector. This project is not just about coding, it's about solving a real world cybersecurity problem using Python. In this video, we will cover what cryptojacking is, why it matters, how our system works, detailed explanation of the modules, a live demo of the system, and tips to build similar kind of project. By end of this video, you won't just know about this project, how it works, but you will be inspired to try building your own version of this. Let's begin. Let's understand the problem. What is cryptojacking? Cryptojacking is when hacker secretly uses your computer to mine their cryptocurrency without your permission. Think of cryptocurrency mining like solving a huge puzzle. It requires a lot of CPU and GPU power, right? Hacker do not want to spend money either on electricity nor on hardware. So instead of spending his money, he thinks of spending your money, so he hijacks your system so that he can use your machine and resources to mine his cryptocurrency miner. Let's imagine if your neighbor connected his AC to your electricity meter, okay, without taking your permission. What will happen? You will end up paying the electricity bill and he will enjoy the air. That's exactly what cryptojacking does. It steals your CPU power, GPU power, and electricity power. As a effect, the system becomes slow. The laptop overheats. The battery drains too faster. And as a long-term damage, your hardware get damaged. Along with this, the electricity bills increases. You might be wondering, if these are the effects, why it is very hard to detect it? Because cryptojacking does not show random pop-ups, notes like other malware. It does its work silently. So that's the reason I wanted to build a tool that will detect it a bit automatically. You might be wondering, why did I choose this project? As we know, this is not just a textbook problem. It's something we actually face. Along with this, I got to implement Python, operating system, networking, machine learning concept, all in one project. Project like this impresses the interviewer, as they show you can solve a real world problem. And lastly, I wanted to show that you can tackle a problem like cybersecurity even with the basic coding. Remember, don't wait to master everything in one go. Start small, build one feature, expand it, learn it. This is how the projects are built, right? Now, let's go to our project. So, I have built an application using GUI tkinter in Python. This application has four main features. File scanning, scans the file for mining keywords. Process monitor, checks the running processes on the CPU use. Network monitor, detects the connection to the mining pool servers. And machine learning model that predicts malicious behavior using system activity data. So, whenever we click on the button or whenever we implement a process, the results are shown in the outbox and saved into a log file called as detection.log. So whenever we run any process, anything, each and every log is registered in this file. So let's walk through the code. Now we will look into our first module file, that is util.py. Utils basically stands for utilities. It is like a helper toolbox for the whole project. So without this module, no other module could work. So to summarize this module, util is our toolbox. It stores threat intelligent list, logging functions, and even synthetic data generator. This makes the rest of our project clean and reusable. Without this file, our code or our project would look messy and repetitive, as we need to call log event for every module. Now let's move to our next file, that is file scanner. Talking about imports and constants, we have imported OS library that is used for file system operation. That means walking through the directories and joining the paths. Then we have imported log event. We have imported the centralized logger from util.py that is used to write the detection logs and print it to the console. Then we have defined some common malicious signature. They are a short curated keywords that are commonly seen in crypto miners. For example, stratum, that is mining protocol, xmrig, miner gate, they are popular miners, and xmr, kryptonite, they refer to as Monero mining indicators. Then we have a function called as scan file. So in this, what it is done is, we take an input, that is entire file as a string. We normalize it to a lowercase so that it matches and which are case sensitive. We loop over our signature and collect if that appears in the file, and if we find and at least one of the warning or one of the signature, a warning is logged and the boolean value truth is written. Otherwise, if it is a normal log, it returns false. So our last function is scanpath function. Scanpath function goes through every file in the folder, looks inside them, and check if they contain any malicious keywords such as xmr, stratum, xmrig, etc. Now let's see how this function take place step by step. First, we exclude the unwanted folders. Like if we give it a folder called as node module or a virtual environment folder, then it will skip that folders in order to save time. Then this function will go through or will walk through every file in the folder. By using os.walk, it will visit to every subfolder and file that is stored in that particular folder. Then it will open each file in binary mode. It will try to decode it as UTF-8 format first, and then if it fails, then it will fall back to the Latin 1 format. Why this is done is, this avoids the crashes from the weird file encoding. Then a scan file function is called to see if any malicious signature is present or not. Then the detection that is done by this function is saved. Like if the detection is suspicious, an entry is added, the name of in the following format, the name of the file, the path to that file, the signature that is been encountered, and Yara. See, here you can see. So this is the file scanner that is found malicious or suspicious. This is the format in which it is stored, like the timestamp, the type of the information, that is whether it is an information, whether it is a warning, or whether it is an error. Then what is detected? A suspicious file is detected. And why this suspicious file is detected? Because this file has signature xmr, and at the end logs are made that how many suspicious files are found, how many non-suspicious files are found, etc. So our next module is network.py. In this model, we have imported three libraries such as socket that help us to work with the IP addresses and the host name. Then psutil, it is a library to read the system details. Here we use it to list the network connections. Then we have imported log event, that is log that logs the messages. Then we have imported default mining domain and default mining ports, that are the list of known suspicious domain and ports that are related to cryptocurrency. Then we have mentioned defined a reverse DNS function. What it is done is, when an IP address is given to this function tries to find the host name behind that IP address, and if the lookup fails, it just return an empty string. And identifying this host name help us to match the mining ports or mining domain with the suspicious one. Then we have defined a snapshot connection function, which is the main function of the module. What it does, it's look for all the active TCP connections on your system, collects the data like local IP address, remote IP address, and process name, flag connections if they talk to suspicious domain or port, and it checks whether the flags that are connected, or the ports or the domain IP address, etc., that are connected to suspicious one, then a error is reported, and as a result it reports the list of dictionaries. Then once we get all the current TCP connections, looping is carried out through each of them one by one. And once looping is done, we start with an empty list for alerts to collect the activities that are suspicious in it. Then we have mentioned local IP address, that is IP address and port number on your machine. And then we have mentioned remote IP address, that is IP address and port number of the server of your app. Means basically remote address is IP or port address of the server that our computer is talking to. After this defining is done, each connection belongs to some process. So we grab each one of the process, and then we mention the process ID, the app name, and the full path to the program. If we can't access that such type of program, we skip it. Then if remote port is one of the suspicious one, we add a reason to it why it is suspicious. Then do a reverse DNS lookup of the remote IP address to get the host name. And if the host name that we have got matches the known mining domain, then we add another reason to it. Once everything is done, if there are reasons, we build a if there are multiple reasons, we build a dictionary with a local address, remote address, host name, process ID, name, executable path, reason why it is suspicious, we log it as a warning, and add it to the alert list. And if we found nothing, that is log is everything clean, Then we return alert list to be empty. So this is what the network module does. Our next module is ML model module. In this, we have imported various libraries such as NumPy, that is used for random numbers and array, pandas to create a dataset in a table format, skitlearn, that is sklearn, that is a machine learning library. In that, we have imported train test split, that splits the data into training and testing sets. Then we have imported random forest classifier. It is an assemble ML model. Then SVC, that is support vector classifier, for which is good for classification problem. Logistic regression, which is a simple classifier. Then accuracy score, that measures how well the module performs. Then a log event, that logs the message in our detection.log file. Then we have generated the data by creating a function, generate data. In this, what it is done is, we create a fake data for training ML models. Each row has three values, that is CPU usage, RAM usage, and network connections, and label. And then labeling is done. If the process is malicious or suspicious, it is assigned label 1, and if it is not suspicious, then it is assigned 0, which is this let us to train the model without needing a real malware sample. As we know, in most of our PCs are well secured or well protected. So crypto mining is hardly possible in our PCs, and therefore, to check our code, to check whether it is working or not, we are creating this dummy kind of a data set. Then, so our next function is a train model. In this, we train the above data using three ML models, that is random forest classifier, SVM, that is support vector machine, and logistic regression. Once we have trained the data with these three ML models, then we prepare a message showing the results of all the modules. We log that message. That means it goes to the console as well as detection.log file, and we return the file. So basically, this is all about the ML classification done that on the generated data. Let's go to our live demo. So this is our UI page. At left hand side, you can see there are various fields such as dashboard, file scan, process, network, ML lab, alert center, settings, etc. On the right hand side, you can see the CPU use of last 60 minutes in a graph type format, and on left side of that you can see a threat meter. So whenever we scan file or process a snapshot or process a network, if there is any risk, it will be shown in the threat meter. So let's start with scan file. We'll select a folder. Let's say I have selected this folder, website folder, and there was a suspicious file in that, so it returns found one suspicious file. Okay, so this it is mentioned below also, the file name and the signature, due to which uh, it is made malicious. And let's see, we'll check our second file. So b when and next to that, on left hand side, you can see a threat meter. So whenever we scan a file, we check the process snapshot or network snapshot. It gives us the status whether the last scan that we have made is malicious, what is the, or it is not malicious, what is the severity of that analysis, etc. So let's start with our first module, file scan. Select a folder. So let's see, I selected a folder called as log. So no suspicious file found. Okay. So if no suspicious file is found, it will not be displayed on the below table. And now I have two files in my laptop that contains malicious signature. Let's add those and check the result. So proposal and paper. See, once suspicious file found, and which signature is found, xmr signature is found, and where it is found, the path of the path to that file is also given. Okay, so once our scanning is done, see, elevated 35% of risk. So this risk meter shows the risk of the last scan. Now let's do a process snapshot. One suspicious process found. So when we click on take snapshot, what it is done is, it detects each and every file, each and every process that is running in our PC at backend. And if any suspicious file is found, that is, if the use of that process is more, CPU use of that process is more than 70%, and the use of memory process is more than 25%, these two conditions are checked. If CPU process is above 70%, it will be considered as malicious. If the memory use of that process is more than 25%, then also it will consider as malicious. So here, as our one of the processes found malicious, it is displayed along with process ID, the name of the process, the CPU use of the process, the memory use, and reason why it is malicious. See, when we do process scanning, the risk meter shows that that process has 60% of risk. That is a very high risk. So we should manage that process, or we should take action against that process. Let's now check for network analysis. Snapshot connection. See, there is no malicious connection found. Therefore, nothing is displayed in that particular file. And module, that is alert center, which basically gives each and every information, or each and every process that we have done in the above models. uh, like, if we have done process scanning, then at what time we have done process scanning, what type of detection we have done, what are its detail, what is its severity, etc. It is given by it is given in this alert center. And this is our last model. Then we have setting wala part, that is not, that is not built very properly. So this is my overall project. I hope you like this project, and you'll try building such type of project in future. Thank you.